Welcome to This Explainer. Today we're diving deep into the world of document databases. And honestly, we are going to build a completely new mental model for how you structure your data. If you're a beginner to MongoDB, or especially if you're coming from a traditional, strict, relational background, get ready because we are going to fundamentally change how you think about database design. So let's just start by thinking about how incredibly restrictive traditional databases can feel sometimes. You know that feeling when you're forced to cram three-dimensional, interconnected, kind of messy real-world realities into perfectly flat two-dimensional tables? It takes a whole lot of forcing, slicing, and dicing just to make it work, right? Well, that's exactly what tabular databases demand from us. But document databases, they offer a completely different and honestly way more natural approach. Here is our quick game plan for today. First, tabular versus document models. Second, the core methodology. Third, phase 1, the workload. Fourth, phase 2, identify relationships. And finally, phase 3, apply patterns. All right, kicking things off with section 1, tabular versus document models. Let's wipe the slate clean and look at the real, fundamental differences between traditional tabular databases and flexible JSON-based document databases, like MongoDB. This quote brilliantly illustrates that core difference. Think about a car. If you want to store a car in a traditional tabular database, you literally have to break it up into pieces. You put the engine on one shelf, the wheels on another table, the doors somewhere else. And then to actually drive the car, or in database terms, to query the data, you have to run these heavy, expensive join operations just to reassemble all those parts. But with a document model, the car remains completely whole as a single document. The wheels and engine are embedded right there. The rule of thumb is what is used together in the application is stored together in the database, making it incredibly fast and ready to go. Now this is a total game changer. Notice the complete inversion of how you actually start a project. In the tabular world, you usually lock yourself in a room, define this rigid schema first, and then you're forced to write your application and your queries to fit that predefined box. But with document databases, it is the exact opposite. You identify your workload and the specific queries you need to run first. The actual questions you want to ask your database are what dictate its ultimate shape. Moving right along to section 2, the core modeling methodology. With that massive paradigm shift firmly in our minds, let's look at the overarching framework that's going to guide our actual design process. Okay, before we map out a single field, you absolutely must figure out where your project falls on the spectrum of the ultimate trade-off, simplicity versus performance. If it's a quick side project by a solo dev, you obviously want simplicity. But if it's a massive, high-traffic global app, you gotta design for extreme performance. But if you aren't completely sure, always build for simplicity first. Why? Because it is infinitely easier to optimize a simple system later on than it is to untangle and remove deep complexity from something you over-engineered from day one. So to make sure your database is perfectly tailored to your application's needs, you just follow these 3 precise steps. Step 1, describe the workload. Step 2, identify the relationships. And step 3, apply schema patterns. Let's break these down. Which brings us to section 3, phase 1, the workload. Let's make this concrete using a hypothetical global coffee franchise we'll call Beyond the Star Coffee. Picture this, we are launching 10,000 coffee shops worldwide. We've got intelligent shelves tracking inventory, connected IoT coffee machines, and we want to capture data from literally every single cup of coffee poured. To really understand our workload, we have to list out all our expected operations. We need to know exactly what this database is going to be doing day in and day out. Things like recording every time a coffee bag is taken off a shelf, or logging the precise temperature of millions of individual cups of coffee. And as we list those out, we have to qualify them because not all data is created equal. For example, tracking our coffee bag inventory on those smart shelves, that is a critical right. If the network blips, we absolutely cannot afford to lose that data, or our whole supply chain breaks down. But logging the temperature of a coffee cup just for some background analytics, that is a non-critical rate. If we lose 1 out of a million temperature pings, no big deal. Categorizing your data like this saves unbelievable amounts of system overhead simply because we don't force the database to strictly protect data that just doesn't need it. Plus, we have to quantify this workload. You can't just look at an average day. Quantifying your workload means designing your system to handle the absolute peak bursts. For our coffee shop, think about that crazy morning rush. A massive 30% of all our daily operations might happen in a single chaotic 1-hour window. Your database has to be modeled to survive that specific, brutal hour, not just a lazy Tuesday afternoon. And quantifying also means predicting your storage.
370 gigabytes. That's the storage we'd need for just 1 year of our coffee cup analytics data. Now compare that to the incredibly tiny 3.7 gigabytes needed for the shelf weight sensors. Seeing that stark contrast instantly tells us exactly where we need to focus our optimization efforts.
All right, section 4, phase 2, identify relationships. Once we have a really deep understanding of our workload sizes, our peak queries, and what's critical, we move on to figuring out how all these different pieces of data actually interact with each other. Looking at our coffee empire, it's like a giant puzzle. We have several distinct entities we need to map out. We've got the physical stores, the smart coffee machines, the shelves, the coffee bags themselves, the cups, and the sensor weightings. Just like you would do in an old-school entity relationship diagram, we map out how they connect. Do shelves belong to stores? Yep. Do cups belong to machines? You bet. And mapping those entities leads us to literally the single most important question in document modeling. Do you embed or do you reference? If you embed data, you stuff it all inside a single document. Remember the whole car analogy? This gives you blazing fast single reads, but it can make your documents pretty bloated. Now, if you reference data, you link it across different collections. This avoids duplication and keeps your reads tiny, but it means you have to make multiple queries. The really cool part is that your specific workload from phase 1 tells you exactly which path to choose here. Finally, section 5, phase 3, apply patterns. So you mapped your workload, you chose to embed or reference. At this point, your initial design might actually still look kind of relational, and that's fine, because this is exactly where we apply specific schema design patterns. Think of patterns as your heavy artillery, your advanced toolkit. They are highly targeted, powerful structural transformations that you apply directly to your document model. They basically let you bend the traditional rules of data modeling to squeeze out extreme performance boosts tailored to your exact app. Let me give you a couple of really powerful examples. First, we absolutely have to understand the concept of a working set. This is the specific data that must be kept in your server's RAM to ensure fast operations. Because, as we know, reading from RAM is lightning fast compared to fetching from a disk. If your documents are too bloated, they simply won't fit in RAM. This is where you bring in the subset pattern. You literally slice large documents in half so that only the most frequently accessed data sits in that super expensive RAM, while the bulky, rarely used stuff is just referenced elsewhere. And there is a whole toolkit full of these incredible patterns. You've got schema versioning, which lets you upgrade your database structure on the fly with absolutely zero downtime. Or the computed pattern to pre-calculate heavy math so your reads are basically instant. Or the bucket pattern, which is an absolute lifesaver for IoT to group thousands of those smart coffee machine readings by the hour. These patterns are your ultimate secret weapon for scaling gracefully. So as we wrap up this explainer, I want you to take this new workload-first mindset into your own development. Honestly, stop trying to force your data into rigid little tables before you even know what your app needs to do. Ask yourself, for your next big project, where are you going to land on that spectrum between pure simplicity and extreme performance? And how can you leverage the complete flexibility of document databases to build something truly incredible? Think about it.